This is exercise number 2. See that in an electro-pneumatic circuit, 2 double-acting cylinders are used. If a push button switch is pressed, both the cylinders will get forward directions simultaneously. So one switch is enough to give the input to both the cylinders. And then if another push button switch is pressed, both the cylinders will get reverse torque simultaneously. See, when you are going to use one switch and then after that relay and that switch you can use it for both the cylinder solenoid. See, the one connection you can give here, then you can tap in that connection itself, then you can give it to the another cylinder. So the simultaneously you can give the electricities to both the cylinders, both the solenoids, then you can operate both the cylinders at a time. And then if you are giving to another cylinder, another solenoid, that means which solenoid you have to use. Which solenoid you have to use, whether it is single-ended or double-ended. You have to use double-ended. So why we used single-ended last time? Because the reverse torque will be happen automatically. If you stop that and then automatically this 5/2 solenoid position will change, then the air direction will be changed, then automatically it will come back. But in this exercise, you have to energize, then only it will come back. So you are going to energize using one electrical signal to both the solenoid, then it will go front direction, and then if you change the electrical connection, then automatically it will come back. So first electro-pneumatic circuit, how to draw the electro-pneumatic circuit, how many cylinders required? How many cylinders required? You see the electro-pneumatic circuit, not one. How many cylinders? 2 double-acting cylinders are used. So you have to use the 2 double-acting cylinders here. This is one double-acting cylinder and this is another double-acting cylinder. So how many DCV valve, 5/2 DCV valve required? 2 5/2 DCV valves are required. So I am going to draw 2 5/2 DCV, 2 5/2 DCV. This is a symbol for 5/2 DCV. Then this one will come back, this one will flow, and then this one will be taking this one you are giving. So here you are giving, and then here the same thing you are going to give. See there, this one. That. So this here the general. What is that? Service unit. The service unit you are giving here. The service unit meaning is here you have to draw one arrow mark, and then after that here you have to make a connection here, and then after that one switch you have to place. One switch means it is a 3/2 switch. 3/2 switch you are going to place. Then this is a selector switch. This is selector switch, and then after that this is spring return, and then this one you are going to give it to here. So this is general circuit. So the common circuit. So here also you are using another one for this cylinder. For this cylinder, the same circuit I am drawing here. Same circuit I am drawing here. This is the common. So you have to memorize this circuit.
Why was substitute is used?
This one is required for all, because this is a service unit. Service unit means you have to give filter, regulator, lubricator, otherwise it will spoil other components. Maybe wear and tear will spoil, or more pressure will spoil other components. So that's why you have to use these components. So you are going to give it to here, and then you are going to give it to here. So this one will go here, and then this one will go here, and this one will go here, and then this one will go here. So this is one solenoid end. This is first end. This is another one. So this another end you have to show like this. So this is the circuit for this. So the same way you have to give here. Okay. Here same way you are giving here solenoid, and same way you are giving here another solenoid. Okay. See that. This is cylinder 1. Here I am going to give name of this 1 by 1, and this is 1 by 2. The same 1 by 1 you can use it here. Why I will tell later. 1 by 2, and then the cylinder 1. This is cylinder 1.
A1.
cylinder 1 and then cylinder 2, or 1A, 2A you can put. Cylinder 1, cylinder 2. So this is FRL unit. This is on-off switch, on-off. This is FRL. This is on-off. Please wait. I will explain. See, you see that two double acting cylinders are used. So we have kept the two double acting cylinders. See, one is here, another one is here. And for two double acting cylinders, you need 5/2 valve. How many 5/2 valves you require? Two 5/2 valves required. But you have to decide whether it is single-ended or double-ended. Why single-ended or double-ended? We have to decide. See that both the cylinders will get forward direction simultaneously. How it will happen simultaneously? This should open. This should open. The spool should be pushed at that time. Okay, without any delay, it should be pushed. Then only when this is forwarding, and this will also get the forward direction. The same way, when you are releasing this, it will get the reverse direction. Same time, it should get the reverse direction. So when you are going to give the electrical signal, you are going to see that. Suppose you see this is the electrical switch. When I am going to press this, the electrical signal should go here, and also you have to tap another one. It should go to here. Okay, if you are using another one switch, you are going to give here at the same time you are going to give it to here. So this is the logic behind this. Understand? In electrical circuit, you have to keep in your mind this both the things will happen forward direction simultaneously and also the reverse direction simultaneously. So you have to keep in your mind. According to that, you have to design. So this is what the electro pneumatic circuit. So this is enough. So this is not required. So this electrical circuit connection you are going to do in the electrical circuit. So this is electro-pneumatic. You see that this is common, this one and this one is service unit, and then after that you are keeping one double-ended 5/2 solenoid operated DCV. So two DCV you are keeping, and then two cylinders you are keeping. So this is satisfying. See that in an electro-pneumatic circuit, two double-acting cylinders are used. Both if a push button switch is pressed, that we are going to show in the electrical connection, both the cylinders will get forward direction simultaneously. If another push button switch is pressed, both the cylinders will get reverse torque simultaneously. Here we have shown the directional control valve, service unit, and then double acting cylinder. Now we are going to show the electrical circuit. See the electrical circuit. How to do that? The first one what will be there? One switch. One switch. When you are going to press one switch, it should go to where? Both the solenoids. Both the solenoid name is what? One by one. Okay. So I am going to do first one. This is positive, and this one is negative. This one is negative, and then the first one normally open switch. This is dotted line. Then E. This is called the switch 1. When you are going to press the switch 1, where it will go? It will go to one relay, and the relay only. Always you have to use the indirect circuit. So it will go to the A1, and then after that this is a relay. The relay means without any line, you are going to give 1 or 2 triangles, mirror image triangles, then 2 lines, and then after that you are going to connect here. This is A2. Okay, this is the line 1. So and then after that, the line 1 you see here I am giving. The line 1 is continuing in line 3. Then line 2 I am going to draw after that. So this is open, and then if it is closed, then it is going to number 3, not number 2. I am going to leave some space for the number 2. In the number 3, what will happen? Number 3, another one. This is a relay coil. This relay coil I am going to give the name K1, and then I am going to give the K1. The K1 is closed. Where it will go? It will go to which solenoid? It will go to which solenoid? One by one. So solenoid, the same symbol. Then this one it is giving. Then this I am going to give. This is 1 by 1. See here, this is satisfying. See, 1 by 1, both the things. So at a time you can give. So you can tap another one wire, and then after that at a time you can give the electrical connection to both the 1 by 1. Okay, for both the cylinders. So see here, when I am going to press switch, the electrical signal will go to this relay, and then after that, if this circuit is closed, this line is closed, that's what the 3 will operate. So how 3 will operate? It will go here. This is called the third line. This is called third line. The third line here, the relay will be closed, automatically the electrical connection will go to the one by one. Then if you are energizing this one by one, what will happen? What will happen? In both the cylinders, you will get the forward direction. For reverse direction, you have to show in the line number 2, here line number 2. We are, see, if another push button switch is pressed, so you have to show the another push button the same way. Another push button means it is yes, 2. So another push button is pressed, it will go A3, it will go another relay. Another relay I am going to name it as K2. This is K2. Then K2 will operate here. That is the 4th. So you have to show here, if this is closed, this is before that it is open.
It's like a 4th.
It is, which line will follow? It will follow 4th line. The second line will continue in 4th line, not in 3rd line. So here you have to show, this is K2. K2 will close, and then after that it will go to another one solenoid. This is which solenoid? Which solenoid? 1Y2. 1Y2 will operate. If you are giving 1Y2, it will come back. Okay. See, once again you check here. First you have to draw the 2 lines. You have to show the positive and negative. This is 24 volt. You take it 24 volt. Okay. The first line which is saying if your push button switch is pressed, both the cylinders are getting forward direction. See that there is a one switch. If you are pressing, we are showing the indirect circuit means you have to use one relay. So the relay we have fixed here. Then relay will be closed when it is closed. See that this line is continuing in 3rd line. So the relay is closed, it will go to the 1 by 1. 1 by 1 meaning is both the cylinders solenoid. Okay. So here 1 by 1, here 1 by 2. Okay. So the name should be common. Then only the circuit will go to. So that's why we haven't used the 2 by 1. Okay. If it is separate, you have to use the 2 by 2. See that after operating this is operating means you have to use the separate solenoid name. Here, why I have used 1 by 1, because if we are giving the electrical connection at a time, if we are giving then Y11, that meaning is it's going to both the solenoid. Okay, 1 by 1. So that's what I have used the common name for both the solenoids. See that 1 by 1. It's going, if you are closing this relay, it's going to 1 by 1, then 1 by 1 will push the spool, then you will get the forward direction in both the cylinders. Then after that, what will happen? You are pressing the next switch, then after that, it's going to the relay number 2. The relay number 2 will take care of the reverse direction in this industrial application. See, this is the example for 2 cylinder. Okay, the previous one, it is the example for 1 cylinder. Okay, that we use the AND gate logic. Here we are not using any AND gate or OR gate logic, but we are using which logic? Both the cylinders should get the forward direction simultaneously. That means same time, and then both the cylinders should get the reverse direction in the same time. Okay, so for that, how to operate that? This electro-pneumatic and electrical circuit is showing.